gonna do the experiment called Reynolds Apparatus, and we are I3. So before we do the experiment, we will know that what the objective of this experiment and the instrument and procedure and how to calculation to this experiment. So first of all, what is the objective of this experiment?
Okay, for the objective of this experiment, we're gonna perform a Reynolds experiment for determination of different types of flow, which are laminar, turbulence, and transition flow.
For the second part, we should know that what is the instrument in this experiment. So what is the instrument in this experiment first?
Okay, let's go to the instrument of this experiment. First of all, we have to have a pump. So it is used to suck the water into a tube, and then we have a upper tank. So the water is in this tank, and then the most important instrument in this experiment is glass tube. So we can observe the flow in this tube. Okay, and then in this experiment there are two valves. The first one is used to control the velocity of the water, and the second one is a tube to drain the water, so the water will come out and return to this tank, which is a red tank. And this is also important, which is a red dye, and red dye will come out from this dye injector here, the little one. Okay, and then this is a small tank. So a small tank, so a ruler will stick with the tank, so we can measure water level from a ruler. So that's it. That is all the instruction.
For the third part, we should know the procedure of this experiment. So what is the procedure of this experiment, James?
Okay, firstly, we have to fill in the water in this tank and wait for some time until it becomes less. And the next step is we adjust this valve to allow the water to flow through this pipe at a very low velocity. And after that, we have to open this valve to allow the red water to flow through this pipe at a low speed as well. And then we observe the form of the red water, whether it's this laminar, transition, or turbulence flow. And after we can observe these forms of the water, so we have to close this valve, and the water will flow through this pipe into this box. And after we can observe this amount of water, we can measure the volume and to calculate the flow rate and the velocity in the next time. And after that, we repeat this step again and then turn to the calculation part.
So now we're going to turn to the boring part. It's just like calculation, so just follow me and I will show you how to do it, alright? Alright, come in. So now I'm gonna talk about the calculation for the experiment, which is Reynolds apparatus. So first of all, the experiment wanted to find like a critical Reynolds number for this experiment. So from the equation, we will get that Reynolds number is equal to rho V times D over mu. So rho is the density of our waters, and V is the velocity of our flow, and D, we already know that the diameter of the pipe is 47 millimeters. So we already know all the equation, but except one thing that we don't know about velocity of the flow. So that's why we need to calculate the velocity of the flow first. So now we've gone to the second page, is how to find the velocity of the flow. So now we're using the equation of the flow rate, which is the flow rate equal to the area, the cross-section area of the glass tube times the velocity of the flow that we want to know. But however, we didn't know about the flow rate, so we need to go back and then find the flow rate again first. So that's why we turn the next page, how to find the Q dot or the flow rate of us. For the flow rate is equal to the volume of the tank. It means that the area that the cross-section area of the tank times the height that James already described by it, just like the height over here. We will get the volume divided by times that we use to measure from the starting point to the point that we want. So lastly, if we do all the calculation, we got all the parameters that we want, then we can find the critical Reynolds number by turning this equation. So we will got the flow rate from this, and then we will find the velocity of the flow, and lastly we get the critical Reynolds number. So and then we will get it and we do the table that at the result we will do about it later. So that's all about my part.
Now the flow is the laminar flow, so we will find the point that the flow turns to the transition flow. So now it's a transition. So now we will observe the fully turbulent flow.
อะไรใช้คนทำงานด้วยก็ได้เนี่ยดูวิธีการทำเนี่ยต้องทำนี้นะฮะ
ได้แล้วจับแล้วอยู่ถึง10ใช่ไหม
โชโร่ทำท่าทางเป็นงานเป็นการหน่อยดิอย่างนั้นนักวิชาการตัวจริงเนี่ยเอายัง
เสร็จแล้ว Channel of water 5 เซนยัง5 เซนบอก
เดี๋ยวกูบอกเองยังได้แหละแป๊บนึงนะ
10 เซนบอก10 เซนบอก
มันไม่ได้ช้าเร็วขนาดนี้
นั่นมันมีช้าได้หรือว่ามันยังไม่ถูกดูแลนะ
มันก็เกิดดูแลแล้วนะแต่ยิบๆหมดเลย
แป๊บนึงมึง
10 ยัง
ยัง
10 ยังอี
เอาเลย
51แล้ว
มึง10ไหมมึงมองมุมไหนกดได้แล้วไง
กูกดไปแล้ว
โอ้ย
มันต่างกันครึ่งนึงนะ